Good afternoon, everyone. Welcome to the Associate for Contract Packagers and Manufacturers webinar titled, Welcome to the Age of Flexible End-of-Line Packaging. Today's session will show us how to keep up with your customers' ever-changing demands for end-of-line packaging. Technology that is now available to help you prepare for those anticipated market conditions. Additionally, we will learn about the future trends allowing you to successfully plan for what is coming next. Today, we have an expert who will walk us through what will be an interesting and informative session on the future of automation in this industry. I'm Ron Puvak, the Executive Director of the Contract Packaging Association. I'll be your moderator today. Next slide, please. Just a quick overview of CPA. We are the voice for the contract packaging and contract manufacturing industry. We've been around almost 30 years. And part of the reason we do these webinars is our educational focus. Next slide, please. Education is one of our pillars. Webinars, we do presentations at different trade shows. We also have industry exposure through trade shows and conferences. We have a huge marketing program that helps co-mans and co-packs and our members get exposed. Networking, we have our annual event coming up. We'll talk about that in a minute. And of course, our ever popular RFQ tool, and we get over 1,000 requests for quotes each year. Next slide, please. I'd like to call your attention to our annual event, which is rapidly coming to fruition here, called Engage, the Contract Packaging and Manufacturing Experience at Clearwater Beach, Florida. It's going to be March 1st through the 3rd. Sessions are awesome. They have a great program, networking opportunities, and it's only a 1.5 day program, so you're not out of the office that much. We look forward to seeing you there, and if you want more information, you'll see that on our website under Engage. So let's talk a few things real quick. Housekeeping. All attendees are on mute. At the end of today's session, a brief survey will come your way. Please provide us with your feedback. That's the only way we make these webinars better and much more informative. The entire webinar is being recorded. Within 24 to 48 hours, an email will be sent to you with a link with the recorded session and the survey. There also is going to be a Q&A session at the end of this presentation. You'll see on your screen there's a question box. Please, if you have any questions, put them in there and we'll get them answered as we can. So let's get started today with today's webinar. Today's topic is going to be presented by Rodney Grounds. He's the Vice President of ROBOPAC USA. Rodney began his career as a commodities trader with Dillon Gage. After a successful stint as a stockbroker with Dane Rasher, Rodney's career growth led him to a position of capital equipment, regional sales manager for SCM Group, the leading producer of machinery and systems for woodworking industry. Since 2017, Rodney has been Vice President of Sales for ROBOPAC, the world's largest secondary packaging equipment company. His extensive work with reduction of stretch films while maintaining load containment has made him a leading expert in the secondary packaging sustainability. Rodney, advance your slides and let's get started.
Thank you very much, and thank all of you who are in attendance today for taking the time out to listen to us talk about flexible automation in end-of-line packaging. My name, of course, is Rodney Grounds. I have been with ROBOPAC since 2017 in the role of Vice President of Sales, and prior to that as a Regional Sales Manager. ROBOPAC has a unique perspective because we have so many different end-of-line machinery product categories. We manufacture depalletizers, case packers, palletizers, stretch wrappers, and even laser-guided vehicles. And so today we'll be touching on the packaging process and where we as a company have tried to focus our efforts in making our automation flexible. So the first question is why automate? And in the co-manufacturing and co-packing segment, it has not always been ideal to automate things, but in the current climate that we have today, automation is key. As you all know, it's very tough to find any labor out there in any of the markets, especially any kind of labor with specialized skills that might be worthy of your operations. So what we'll look at today is the secondary packaging process. And we break it down and try to keep it in real simple terms. Basically, we pack it, we stack it, we wrap it, and then we move it. And in each one of those categories, today I'm going to try to show you some features that we've tried to incorporate over the last several years to make that automation of these processes very flexible, user-friendly, and operator-friendly. So why would we automate case packing? Case packing traditionally in the US can be either done in an RSC style case or a bliss case, a tray, or a wraparound case. A lot of our equipment features focuses around the wraparound case, tray and film packing or film only type packing bundling. In the past, maybe you could manually pack cases by having a large workforce, bringing product, manually placing it into a case, and then advancing the case to a case sealer. Under today's circumstance, even if you can find the labor, sometimes with social distancing and everything else that is prevalent in this time of a pandemic, it's just not feasible or practical to manually pack cases. So, what are your considerations to move that from a manual operation to an automated operation? What are the things that you need to be successful? I think a lot of time when we think about flexible automation, we immediately, our mind drifts to a robotic work cell that is very highly flexible. But typically the giveaway, what you give away to do that type of automation is throughput capacity. And many of you listening today probably have throughput capacity requirements that robotic work cells may not be a perfect match for. So if we look at a traditional automation, a traditional case packing machine, what are the things that are important to incorporate in something like that to make sure it's flexible and user friendly? So we looked at things like automated toolless quick changeovers where you can go from one product to the next. We looked at designing machines that could accommodate many package formats, machines that might be able to do a film only bundle and then at the next run do a full wraparound case on the same machine. And then again, automation that can allow for throughput capacity that's required in the real world. So I wanted to talk about one of the machines that we have that accomplishes that, and that's what we call our TC series machine, and we call it a combination or a combi machine because the combination of formats that can be run on this machine is very wide. A machine like this can run not only a wraparound case like you see here on the bottom, it can run a tray and film pack, a pad and film pack, or a film only pack. This machine can run all those formats in the same machine. You don't have to have multiple machines dedicated to a format. And with a servo changeover, you can accommodate quick changeovers from one of these formats to the next. The other things that we've really been pushed to do in these wraparound type case packers is to provide shelf ready packaging. That seems to be a big push, and I have worked with several people in your industry that are looking to provide their customers with these shelf ready type packs. So just to give you an idea of what I'm talking about, this is a nice 3D animation of how this machine is designed and some of the design features. Probably about 6 years ago, we really sunk our teeth into this concept of flexible automation. So we did some things to make the machine more user-friendly. Things that were very simple in design, but made a huge difference. Like we widened our machine frame, and we did that to accommodate some automation, but also to make it easier for operators and maintenance people. Simple things like putting steps inside the machine to give you better access from the outside in by putting full-length sliding doors that can be opened all the way to expose 2/3 of the machine where you can do maintenance in food and beverage environments, making those doors very easy to take off, as you could see in the video there, for cleaning. All of the machines, again, a kind of a creature comfort, LED lighting in the machines, even in a very bright, well-lit factory inside of a machine, it can be dark. All these things are to help operators and maintenance people with the machine. We looked at how blanks are fed into the machine. We use a 90-degree dual magazine that allows you to put blanks on the machine as it's running. taking the film rolls outside of the machine and providing a system for automatically splicing film tails where you don't have to stop down the machine to change rolls of film. As one expires, the film tail is welded to the new roll. All of that controlled with servo motors, so you have precise tensioning of the film. Again, making it user-friendly and maintenance-friendly. There are, a lot of changeovers to be made when you're running multiple formats. So we incorporated a servo-driven automatic format change from the HMI. We can control the magazine dimensions. We can control the channels or the lanes the product goes through, the widths of those dimensions, the height dimensions, the pitch of the chains, depending on your product size. All that is programmed in advance and called up with a touch of a button. One of the other things we do, all machines have wear components on a packer like this. The knife that cuts the film is one of those. We put it on a THK guideway system so it can be pulled external from the machine very easily, and that changed in a rapid amount of time. So again, the flexibility we're talking about is the flexibility of formats, the flexibility of ease of use. This particular machine has a very high efficiency tunnel with a pneumatic motor that will kick on if the machine happens to lose power where you don't have any problem. But as we watch the rest of this video, we'll see a servo picking device picking, alternating from the two different blank magazines. This first is going to show us the machine running a wraparound, a full wraparound corrugate case. Then with a quick changeover, we can go from a full wraparound case to the next format we're going to take a look at here would be our tray and film type format. All of these formats are very, very popular in the food and beverage industry in particular. Now, the same machine that ran a full case now is running a tray with a film overwrap. And then to take it one step further, we can run the same machine with a film only bundle. So smaller bundles, possibly in film only, can be run on these machines as well. All with a matter of a servo changeover. When you run to a film only, there isn't a manual adjustment of adding some bed plates for support, but still a very, very quick and reliable changeover. That allows the flexibility of changing package formats multiple times in a day without stopping down the lines for hours at a time trying to make a format change, or having multiple lines that you would have eat up a lot of footprint in your shop with different machines for different functions. So what I wanted to show you, we saw a 3D animation. I'll kind of go through these videos just to show you real life applications. This is a combination machine showing, first of all, a steel can. This is unique. This is a steel can in a wraparound case, but as you can see, we're going to stack 2 layers of can. We use a magnetic stacker to stack layers of cans and then run it through a wraparound case like we saw on the 3D animation. The next part of this video, after it shows us completing these wraparound cases, we'll see the flexibility of the machine going from a big, heavy, double stack 4x3 steel can to now a dual lane, single 3x1 with a film only. So you see here we have now individual cans coming. We're separating them out into 2 channels of 3x1 with a film only. So on the same machine, we have the flexibility of running a big, heavy wraparound case and then maybe a shelf ready or a retail bundle. And this can be with clear or printed film. I wanted to touch a little bit, we talk about the flexibility of these machines. As they're standardly configured, you have a lot of flexibility, but we also have special options for different kind of functions. This is a dairy application. It's a dairy application, and you see some laning of a product that could be very difficult to handle. These type of tapered cups can be a problem for some people, but we have solutions for the material handling of these difficult products to handle. And this particular video shows a nice application, again, of stacking. We're making a separation using electronic separation fingers. We come in, and now this is a pad and film that's double stacked and then wrapped with shrink. And so again, just showing you the flexibility of the system here, that you can equip these machines to give you the utmost in flexibility for food, beverage, home and personal care type packs. So hopefully meeting any challenges that your customers might give you. Another option that's available in this series of machine to add flexibility is partition inserting. Some customers demand a partition to protect the product internally. In most cases, this is a separate machine with not a lot of automation. It's usually a pretty big changeover. But in our machine, we can insert a partition inserter right over the infeed of a wraparound case packer. As you see, we're picking from a magazine. We're opening the partition and dropping them in the package format before it goes into a wraparound caser, which you'll see here in just a moment. Again, all one machine frame. Relatively compact in design. You don't have to worry about having an erector and conveying and a packer and conveying and then a sealer. It's a kind of an all-in-one solution with maximum flexibility. These machines are available in throughput capacity. That's the other flexibility I wanted to talk about. In anywhere from ranges of about 30 cases per minute all the way up to about 80 cases a minute in this series. Maybe you don't need all that flexibility. Maybe you never get asked to do wraparound cases or whatever. There's also in our standard bundling machines a lot of flexibility built in. This is a quick video that shows just an idea of the flexibility of packs that can be run in just our standard bundler machine. This is a tray and film machine, just showing everything from steel cans to glass bottles to PET bottles. Again, these machines are available with complete auto servo changeovers for very quick and reliable changeovers, which allows you to be flexible to run small batches at high throughput capacities. So just to give you an idea, even on a machine that's not what we call our combi, there's a lot of built-in flexibility. That brings us to kind of the next step. We talked about packing it. Now we're going to talk about stacking it. And this is an area that in the last 2 years has grown tremendously for us. It's an area where a lot of people were doing palletizing manually. With the shortage in labor, we came up with some ideas to make our palletizers flexible, easy to use, cost effective with small footprints, and I'll share those with you. The first thing I'm going to show you is kind of a result of market demand. Companies that have very slow producing lines, but they don't want to manually or can't manually palletize, but they don't have room for a traditional palletizer that's got a huge footprint and cost a fortune. So we came up with a machine that is a very small footprint machine. This is called our pick and place. Basically, it's an 8 foot by 10 foot footprint. It would go at the end of a line. It's up for about 10 to 12 cases a minute. But the idea would be that you can automate a palletizing situation that in the past may have taken a much larger footprint and a lot extra money. This is a very affordable solution, coming in at just around $100,000 for this type of solution. But you see some of the advantages is we're handling cases from the bottom, which also lends to flexibility. We don't have to worry. We could be doing unwrapped trays, and because we're supporting the product from the bottom, we can pick them and stack them. Whereas if you're locked into something that's picking the cases from the top all the time, that could be a problem and limit your flexibility of cases that you can bring into the machine. Again, small footprint flexibility, flexibility of cases that the machine will handle. The other type of palletizing flexibility that we've designed is palletizers that actually do multiple functions, not only palletizing, but stretch wrapping at the same time, what we call concurrent stretch wrapping. A machine like this is a very small footprint, a very affordable price. The footprint on this machine is about 15 feet by 18 feet. And what this machine does is it concurrently stretch wraps. And what that means is as we're building product layers, we're actually stretch wrapping those layers as we're building them. And I'll show you a video of that. This video is kind of unique. It's actually done in 3 frames. It is the product in feed is going to be shown on the left. The product coming in and where we're building rows is in the middle, and then the layer deposit and stretch wrapping is in the right-hand side of this screen. So all 3 screens will be running at the same time to illustrate what concurrent stretch wrapping, the flexibility of concurrent stretch wrapping is. So you notice over here on the right screen, we just dropped a layer. You'll see some stretch film being blown from the stretch film head over and laid on top of the first layer. As we're getting ready to drop this next layer, you can see the end feed's still working, rows are still being pushed out to a layer head, but we're stretch wrapping that as it's going on. So if you look kind of in the middle screen behind the layer head, you'll see that palletizer, that the stretch wrapper wrapping. We've kind of broke it out over here to the right where you can see it a little bit more clearly. But all that activity is going on one time. So the benefit here is that you have the flexibility of multiple different layer patterns without the possibility of when they exit the machine unwrapped, them separating or falling apart. You're wrapping them as you are palletizing layer by layer. So you're going to have a full pallet build ejected from this machine, totally stretch wrapped, so it can go directly to storage or be loaded on a truck. Again, the idea here is providing the flexibility of a very small footprint machine that combines functions to get the most flexibility out of it. I talked earlier about robotic work cells, and there is one area that we do a lot with robotics, and that is in palletizing. So what you've seen so far, the 2 palletizers that I've shown, are very good for single in feed. So one SKU coming into an area where we're going to build a pallet out of that one SKU, or one in feed and one pallet build station. Many customers want the flexibility to run multiple lines into one palletizer and not have a dedicated palletizer for each line. In that case, we can offer robotic palletizing. Typically, robotic palletizing comes into play when we do have those multiple in feeds coming to one palletizer. And this is a nice video that shows an illustration. This is 2 product in feeds, 2 different SKUs, 2 pallet build stations. And then we have stations where empty pallets are coming in. A lot of times we like to use a mechanical style gripper, again, where we have positive case picking, but also where we can pick our pallets. And we equip these with vacuum devices where we can also pick slip sheets to go in between the layers of the pallet. Depending on the type of throughput capacity needed, we typically would pick either rows for higher throughput capacity or individual cases for slower throughput capacity. These gripper heads, mechanical gripper heads, are very flexible. You can pick up a complete row of product. You can pick up an individual case. You can pick up a row of product and then separate that row into multiple stacks, as you'll see here in just a moment here. We set a box, opened, and picked up. So robotic palletizing is something that we certainly have seen an uptick in. It's not always the answer, but it's a really good answer when you have multiple products coming into one palletizer. So we've talked about packing it, we've talked about stacking it. Now we'll talk about wrapping it. Stretch wrapping is something that no one really likes to do. You have to do it to transport your product and get it to its destination in good order. A lot of people still like to hand wrap. That's becoming less and less prevalent as we have the labor shortages, and people, it's the worst job in the factory to hand stretch wrap, I think. So there's a couple of ways we look at automating the stretch wrapping process, and it could be very simple automation. A lot of you guys are probably very similar with most of the pictures here. Turntable style stretch wrappers, rotary arm style stretch wrappers, maybe horizontal stretch wrappers for bundling products together, or the robot, which is a machine that's a little bit unique to ROBOPAC, which is a mobile portable stretch wrapper. So I just wanted to kind of give you, first of all, an idea of this robot stretch wrapper. It's a very portable, flexible type solution. One thing I'll talk as this video is going, I'll talk about what we do at ROBOPAC. We've got a patented technology that allows us to vary the pre-stretch and the containment force through our film delivery system, which allows us to save about 20% to 50% on film consumption. And it allows us to make sure that we're wrapping each layer with the proper containment. So strategically putting containment force on a pallet. We have here in Georgia a large tech lab with shaker tables and acceleration sleds, and we test these type of claims out all the time. And what we found out is this type of stretch head that we use that allows you to save or use less plastic, consume less plastic on the pallet and still get the same containment force, not only helps customers with the bottom line, you're not using as much plastic, you're not spending as much money, but we have several of the large Fortune 50 type food and beverage companies who've come to us and requested this style of carriage, stretch film carriage, to accommodate or to alleviate some sustainability concerns that people have these sustainability committees. So they think if they can reduce the amount of plastic going on a pallet by 20 to 50%, then that's a way to reduce plastic out of the waste stream. So that's a nice clean video of this mobile robot that you drive to the pallet load and then attach the film and let the machine wrap automatically while the operator's doing another job, so it's done in mask time. But I wanted to show you kind of a real life example of this flexible technology in action. This is a large national office supply company in one of their distribution centers, and you can see the type of load here is a very difficult load to wrap. There's heavy products and there's light products. About 2/3 of the way up, there's a big white board that's sitting there on top of the stack, and then at the very top, to make it even more difficult, there's a really lightweight bag of bubble wrap. So this technology of the film carriage with the variable pre-stretch and the variable force to load, one of the things it'll allow us to do is wrap any type of load, even ones that would be, under most circumstances, very prone to being pulled over by the force of the stretch film on the load. So what this allows us to do is ramp up the pre-stretch of the film to a very high level and apply the film at a very low tension on the way up. So we tack all the product together. Now, make sure we have this wrapped correctly where it's going to reach its destination. Okay, you'll see here we start to put a little bit more force on the load, but the load doesn't fall over because we've already tacked it down with light force. So again, the ability to wrap any size load, wrap anywhere in the factory, eliminate hand wrapping, save a lot of money on film. It's another just example of some very, very simple, very cost-effective automation that could be put in your production facilities. When you also talk about wrapping it or stretch wrapping, you talk about full automated systems. There is a great demand to match up or pair up with high production lines, automatic stretch wrappers, receiving products from high performance palletizers and needing to be stretch wrapped. So in that regard, we've tried to make these machines very user friendly, very flexible in what they do, with a lot of features that make sure that we're going to be able to provide the specific wrap pattern needed for a particular type of product to make sure it gets to its destination in good order. This is what we call our rotary ring machine. It's our highest throughput capacity machine. It's a machine that will wrap up to about 200 pallet loads per hour. We have machines starting at about 20 pallet loads per hour all the way up to this 200 pallet load per hour mark. You'll see some things in this video that are unique. We have the ability to make what we call a waterproof load by applying a top sheet of plastic on the load as we wrap it. We can make sure that we always capture the pallet with film, so we secure the load to the pallet by incorporating a pallet lifter, so we can make sure we can get the film down onto the pallet. A lot of these are very simple ideas, but again, allows us the flexibility to automate. You see here, there's a little, looks like a cord or a rope. We can apply pressure to the web of the film to cause what we call a roping effect. So that locks into the wood of the pallet and locks your load onto the pallet. Or you can apply that rope all the way through your product to kind of be a reinforcement band all the way up and all the way down, or like a belt on the system. I had mentioned to you about this technology we have that allows us to strategically place film. So with our machine sees this pallet as 12 different layers, and in any one of those 12 layers, we can change the machine speed, the pre-stretch, the containment force, the number of revolutions. So it allows us to scientifically design a wrap pattern for your product. This is a nice feature of the machine, the film breaking cycle, film test break cycle. So basically, today, what we can do is put a roll of film on the machine, and we can ramp up the pre-stretch in 1% increments until the film breaks. That lets us know for production runs what your film will actually stretch before breaking, where we can prevent film breaks due to overstretching the film. The other thing that's flexible about these machines, if you have really high speed stretch wrappers, you go through a lot of film. You don't want to have lines down while operators are coming in trying to change film rolls. So we can do an automatic film roll change. Once the roll expires, the machine will lock into place and a little arm will come in to pick up the old cardboard core of the film. Once that core is deposited, you'll see in the background a little garage door, or a door will open up, and there's a roll of film sitting back there on a film trolley. It'll come in and engage with the machine, and the machine will pick up a new roll of film and start wrapping again. The whole process takes about 1 minute and 15 seconds, but it's done autonomously without anybody there. So again, flexibility in allowing you to have more autonomous time running the stretch wrapper without having somebody tend to it. Kind of move on to the next part here. So we talked about packing, we talked about the stacking, the wrapping, and now we're going to talk about how we're going to move that around. And this isn't we're hiring at ROBOPAC, but what this sign illustrates is every time I drive by a warehouse, no matter what city in the country I'm in, there's a big "now hiring forklift drivers" sign on the factory. And it's a problem. It's an area that we've seen a huge increase in demand, is how do we replace forklift drivers? At ROBOPAC, we manufacture laser guided vehicles, or autonomous forklifts, basically. And we have a full range, everything from tall reach machines, machines with clamps for doing rolls, double lifts, conveyor lifts, little narrow units to go into aisleways, and then just basic counterbalance trucks that would mimic a standard forklift. You know, why would we use laser guided vehicles? The studies show that they're much safer than a traditional forklift. The machines, and I'll go into here in a moment the different safety systems that are on them, but they're very, very safe. You're going to reduce product damage. You're not going to have that forklift driver that guns the forklift before the pallet is wrapped and the product goes spilling on the floor, or the guy that runs the corner and runs into something else or into a wall. A lot of flexibility. These machines will do anything that a forklift will do. It can work lights out, 3 shifts a day. No one has to be there. And it's an intelligent solution because you can have full tracking and tracing. This machine can relay back to your warehouse management system exactly where pallets have been picked up from and where they're going. It can really reduce production and warehouse calls overall. So how do they work? They are laser guided. People ask me all the time, are they wire guided on the floor, those kind of things? No, they're laser guided. And they work off a kind of a manager station that incorporates 3 softwares: a production manager that is going to call the forklift or the LGV to come pick up a product, the traffic manager that keeps tabs on where all the units are to make sure it's pulling the unit from the closest point and that the units don't run into themselves, and then the warehouse management system, which is something you may already have in place. And all of those 3 things work together to make sure this system works. As I said, they're laser guided. We put reflectors around the warehouse in a manner so that the machine is always scanning for 3 of those to triangulate the position on the floor. Very high degree of accuracy, within a 1/4 inch accuracy, plus or minus 5 millimeters. Talking about the safety, they come with SICK area scanners, so they have 3D area scanning on the units. I like on the bottom of this slide, there's a picture that looks kind of like a big yellow price tag, and that thing that looks like a yellow price tag is an illustration of the area where the machine doesn't stop, but it slows down very, very slow. So if anything gets in that area where the yellow is, it will slow down the machine to a crawl. If something breaches and goes into that red zone, then it stops the machine. The nice thing is once something is out of those zones, the machine just continues on its mission. There's no resetting of the machine or anything. The machine goes along and does its job as soon as whatever's in its way is out of its way. This is just an illustration of the 3D area scanners and a quick video showing some LGVs in service. So again, a very large variety of different types of trucks that are available. You can see here, totally autonomous. This video. This is actually at a lubrication company. Actually, this is a beverage company. This is Mayhew Brewery. I'm sorry. This is almost a lights out facility. A lot of the machines you see in the background, the robotic palletizers, the stretch wrappers, this is a full ROBOPAC project. So you can see here the flexibility of automation. You can run a lights out facility with laser guided vehicles, robotic palletizers, automatic stretch wrappers. This is a double picking up 4 pallets at a time. Again, anything that a forklift can do, for the most part, an LGV can do. The LGV is a process that requires quite a bit of study on both our customer sides and our side. We really need to take a holistic look at what our customers are doing and what they're needing to do and where the routes or missions would be, so we can calculate how many LGVs would be required and that kind of thing. But I can tell you in the last year, and specifically our highest request for quote item is the laser guided vehicle. And it's primarily because there's just not a lot of forklift drivers out there. So with that being said, I think we've covered packing it, stacking it, wrapping it, and moving it. Hopefully today you've seen some ideas where we can use traditional machine automation in a more flexible way to meet throughput demands that you might have. If you need any more information, feel free to visit our website at robopacusa.com. And with that, I guess we can open it up to questions.
Thank you, Rodney. Yes, we do. Let's get some questions out there. And if you have any additional questions that have been coming in or you'd like to send in, please use that question guide. Rodney, let's talk a little bit about, typical ROI. When you build or buy capital equipment, ROI is a major concern. And I know every application is different. What do you guys see when you move into an operation? What can someone expect in the way of an ROI, especially in the co-man co-pack side business?
That's a really great question. And over time, this type of technology, the ROI has changed a bit, especially as we see labor markets going up. But it's not just all labor. A lot of the things that we talked about today, some of the flexibilities we talked about, are things like material savings. So those all get factored in. As a rule of thumb, right now, most of our customers are seeing ROIs or paybacks on this type of equipment. And this is a broad statement, but 18 months or less is typical with systems, like the laser guided vehicles, which by nature are much larger projects, kind of out to that 18-month type range, 18, sometimes 24. But on some of the more simple automation, like one of the simple stretch wrapper, if you figure in the reduction in film, the savings there, you can have almost an immediate payback. I know that's kind of a broad answer to your question, but without really dialing down each application, I hope that gives you an idea of what we're seeing in ROIs in the market today.
Yeah, and probably following up a little bit on the material saving side. If we're looking at the total ROI, is the material saving side a little greater than the equipment, labor reduction side? I mean, are you seeing any kind of tendency there?
Again, that's a great question, and it kind of depends on the application and the machine. So where material savings seems to be exaggerated or what is really a driving factor is on the stretch wrapper side. With this patented film delivery system we have, and we can prove that we can save a customer 20 to 50% on stretch film, really there could be, depending on the customer's throughput capacity, how many pallets they're wrapping a day, there could be an immediate payback on that. So just on the film savings. So in the stretch wrapping segment, film savings and consumable savings is really a big number of the ROI. When you talk about a machine like a palletizer, it really consumes no product, so it's a pure labor savings. And so that relates back more to, you know, the increases in wages right now and the overall lack of skilled labor that's out there. And then our packing machines are somewhere kind of in the middle. We've seen customers redesign packaging formats to try to reduce the amount of consumable materials in those formats. For instance, we've seen people go from a full case to a tray and film, so you have a corrugate savings there. We've seen people reduce, you know, on products that are able to be packed with film only, to reduce the corrugate completely. And then if you still need a complete case, but you're worried about trying to save some corrugate cost, the wraparound cases that we were looking at in these videos, typically you can see somewhere between 5 and 7% in reduction of the materials. So that's again kind of a long-winded answer to your question, but I think it depends on the application. Laser guided vehicle is going to be it's going to be a blended of labor savings, but also total cost of ownership. It's much less expensive to maintain an LGV than it is a traditional forklift. So you can figure in some of the maintenance costs associated with forklift versus LGV, but it's usually a blend, and hopefully that answered your question.
Yeah, it did. And, you know, apparently this is a hot topic because I've seen the questions coming in. Now, you've claimed a 20 to 50% savings in materials, and that is purely because of your system ability to manage the load based on the stretch, the pre-stretch and everything else. Is that truly how that's managed?
Yeah, that's exactly right. And that's a very good point. So a lot of people claim film savings by what we call downgrading the film, going from an 80 gauge film to a 63 gauge film. That's not what we're talking about at all. We're actually talking about the mechanism that pre-stretches the film. So film comes off of a master roll and it goes through two rollers. One roller is turning slow, the other is turning fast, and we're stretching out the film before it goes on the pallet. Everyone can do that. All the competitors can do that. But what our competitors are doing is they have a fixed pre-stretch. There's a set of gears that are fixed, usually at 200 or 250%, and that's what they pre-stretch all the way up and all the way down every pallet they run every day. With our system, we have that same one roller turning slow and the other turning fast, which causes a stretching action. But instead of a fixed gear, we have a independent motor, one on each servo motor on each roller, and we can vary that pre-stretch anywhere within the load that we want to. So what that allows us to do is when we start wrapping a pallet and there's sharp wooden corners, if you stretch the film too much, it becomes very puncture prone. So with this variable pre-stretch, we can start out at 200% like our competitors do, take care of these critical paths, that might cause a puncture. But as we get into the meat of the load or the meat of the pallet, we can ramp up the pre-stretch to get whatever stretch in that film out of the film. So we can get the best economy out of whatever film the customer is using. We're totally agnostic to film. If the film stretches 340%, we'll get 340% out of it. Where our competitors are limited to 250%, that's where their gears are 200%. They can't start out stretching at maximum all the time, or they'll have film tears all the time. So in a kind of a quick, less than technical explanation, hopefully that answers the question. But it's truly film savings because of a mechanism that is getting all the stretch out of the film instead of leaving stretch in the film or meat on the bone.
So that's an interesting point. So you're doing a variety of applications. What are some of the most challenging applications you guys have run into that have, maybe, been very difficult to really automate? Have you found any?
Yeah. So no, I think that's a great question. And again, it kind of goes back to the application. I'll tell you that on the case packing side, some of the things that we see a lot are multi-packs or variety packs or rainbow packs. That is something that requires some upstream automation that's not always easy. It certainly can be done. It's challenging or almost impossible to do it inside of the machine. So it's a combination of some upstream. So I would say that's one thing that's very prevalent in the industry right now is smaller batch sizes, but multiple flavors in these batches. That is one thing that's challenging to flexible automation, but it can be done with the proper combination of some good in-feed technology and then flexible automation as the actual packer. When we talk about palletizing, I think traditionally the thing that's been a big obstacle in palletizing has been the footprint that a palletizer takes up and the cost that it has. And so with co-packers and co-manufacturers, sometimes that is tackled with labor. And so that's where our focus has been and how we're trying to narrow the gap there is to manufacture these palletizers that are very flexible, that can combine multiple operations in one machine and have a small footprint. Then when we talk about stretch wrapping, a lot of times we talk to customers that think, okay, well, this load, I'm making a mixed load. You can't really spin it on a turntable, so we have to hand wrap it. And that's where the little mobile wrapper that I showed you earlier really comes into play and kind of attacks that challenge maybe that other people have.
Mhm. Okay, let's talk a little bit about footprint real quick.
Sure.
You've done a combination machine, which means you've tried to integrate the processes. Give us a sense of the space saving, the floor space savings, your machine versus traditional. Do you have a sense as 30% less, 40%? What is the number? Is there a number?
Yeah, I don't know that you can hang a number on it, but I can kind of give you just an illustration. So again, it depends on throughput capacity. A line that'll run 30 cases a minute, whether it's a traditional line or whether our combi machine, it's going to be shorter than a line that runs 80 packs a minute. That's kind of given. But the alternative solution for if you don't have a combination machine is typically a line that is a case erector, and then you have to take that empty case via conveyor to a case packer. You have to take that case once it's been packed via conveyor to a case sealer. So you have a long line, usually with 3 machines. You have conveying and integration cost. And then when you go to change over the machine, you're doing a changeover on 3 machines instead of 1 machine. The overall length of a line like that typically is longer than ours. I would say probably, and this is real hand wave engineering, somewhere in the 25 to 30% longer than a all-in-one style combination machine. So that's one consideration there. I think the other thing that you need to take into consideration is the ability of one machine frame to do multiple formats could even make a bigger impact than just the simple scenario I just gave you. Maybe if you don't have a machine that'll do all those formats, you would have to have a line dedicated to a tray and film, let's say, and then a separate line dedicated to a full case. So now you're almost doubling your footprint from what this machine will do. So when we consult with our customers, these are all the topics that all these questions are great because they're the questions that we get answered and the questions that we consult about. But we take these things into consideration and we do layouts and can prove out what those footprint savings are.
Sure. Now, integrated machines, combination machines tend to have their own complexities. Is there a higher level of preventative maintenance required for a combination integrated machine than there is in traditional machines?
So I wouldn't say it's, I guess maybe in the past, in the old days, it could be, especially machines that didn't have the ability to do servo from the touchscreen type changeovers. But I think that we have tried to design these flexible, these combination machines to have the features that make the changeover and the maintenance very, very easy, if not easier. Again, if some of the other solutions out there, you're talking about multiple machines. So you're pulling maintenance on a case erector, on a case packer or a case sealer. Now, granted that these machines, these combination machines, kind of have each one of those sections together, but it's on one machine, and most of the time these features have automation associated, especially on the setup where they can be done by a relatively unskilled person from the control panel.
You lead right into my next question. Let's talk about 2 different segments of labor in a plant. We have an operations side, an operator, How trained, how skilled, how knowledgeable does an operator have to be able to do some of those simple changes from one format to the other? Does it require a setup operator or not?
That's another great question, and it's something that we get asked all the time, and quite frankly, over the last 5 years has come a bigger and bigger concern, and it's where a lot of our research and development has gone into. And we call it an idea of a user-centric design. We want to make things easy for operators because we realize the labor pool has shrunk. There's not like in the old days where you could find a machine operator. That's the guy's career. I'm a machine operator, and he has knowledge of how to operate a machine and manually adjust and do those kind of things. A lot of times, the people that we see in operations now may have been a fast food employee or something, and quite frankly, they're much more familiar with an iPhone that's very intuitive and icon driven than they are with a traditional HMI or machine interface. And so we've developed these interfaces on our machine which mimic the touch and feel and look of a current day cell phone, where they're icon driven, they're touch screen, they're intuitive, and so those things help a lot. Now, to your point, you may not want that guy doing a full changeover. You may have a shift lead or a manager come and do those kind of things. But as far as turning on the machine, selecting a pre-done program, turning the machine on and off, it's all done from a touchscreen controller, and it's the idea behind that is to broaden the workforce that could come in and run that machine.
Okay. Well, let's talk about the other side. Let's talk about now the setup and the maintenance folk. Are we requiring more sophistication, more training, more expertise there than, let's say, our traditional plant might see in a more mechanical environment? Are you guys seeing that with your machines?
Yeah, that there is some truth to that, and here's the reason why. First of all, we try to make it as simple as possible. Through the HMI, we have different levels of security, I'll call it. So their operator is able to do certain things. A shift lead or a maintenance person may be able to do something, and then there's a super user or a maintenance manager that has a different level of clearance, so he can do different things on the machines. These machines are, for the most part, electronic machines, not so much mechanical. So we do find out that in the plants that there is a need for somebody that understands these electronics. But how we offset that in a time where maybe these guys aren't available is we allow for monitoring systems and remote diagnostics on these machines. So either through a cellular connection or through a landline, our technicians in Duluth, Georgia, or Portland, Oregon, where our two locations are here, or even in one of our factories around the world, can dial into that machine and start diagnosing and pinpointing and troubleshooting these potential electronic issues. The other thing that helps a lot is we've tried to eliminate a lot of the guesswork when there is a fault. We have very well-defined error codes, which are oftentimes accompanied by a GIF that shows an animation of the area of the machine where there's a fault and what the procedures are to clear that fault, instead of having to pull up a user's manual and find a fault code and read a paragraph about what you need to do. It's all on the HMI these days, and it's all icon or GIF driven, and a person that doesn't read at all could walk through and clear most faults on the machine. So those are all things that we take into consideration. I think we're in an age of an electronics, so a lot of the old style purely mechanical machines are a bit of a thing of the past, but we're trying to make these other things, these modern machines, user friendly for both the operator, the maintenance people, and the technicians.
That's a good question came in. So you're setting up an LGV system. Do you find you have to make a lot of changes in existing warehouse setup to make an LGV work better or more efficiently, or is that not the case?
It could be the case. Most of the time, it's not the case. As I kind of said, LGVs, there's a big discovery period, I'll call it, with a laser guided vehicle. It's a lot of consultation. We have laser guided the vehicle experts that go out and consult and walk the plant and see what's going on. There are some red flags for us when we go into a plant. If a plant has a really poor quality floor, a lot of potholes or big cracks in suspension joints or things, that's not a good place for an LGV. If we go into a plant with extremely wet floors, that could be a red flag. We study the layout, we study the paths where the forklifts are driving right now. Typically, if a forklift can drive through, a laser-guided vehicle can drive through. I'll tell you a little bit about laser-guided vehicle implementation. So once a customer has decided to go with the LGV, they rarely ever replace every forklift at one shot. So we kind of almost always phase these projects in. There'll be a phase 1 and a phase 2, or a phase 1, 2, and 3, or whatever. So the idea is we try to keep the forklifts out of the LGV's ways and the LGVs out of the forklifts ways, but it's usually the LGVs are scalable. Once you get that kind of trifecta of software together, then you can scale that using adding new vehicles. So we usually start with a phased approach where we can accommodate those things. Some things like very narrow aisleways, may be too narrow for an LGV, but of course they would be too narrow for a forklift also. Some types of racks aren't as friendly to LGVs. Sometimes truck loading and those kind of things. There are some requirements we have of the trucks and everything that could affect it. But I would say the high percentage of our customers don't have to go in and redesign the plant to accommodate an LGV. Okay. There are things that we can do to make them more efficient. We can suggest, but typically it's not a complete overhaul of a plant to accommodate an LGV.
Okay, and we're going to run out of time here, but I just want a quick question. I saw you have your TechNet lab in Atlanta. I take that's open for people to come and see the technology, or is that purely a testing lab?
No, it's a service that we provide to our customers to detect and load containment primarily of your palletized loads. We do it as a service. Anyone can schedule a visit to come in, send us their palletized loads. We'll test them with the way they're currently being wrapped, and then we will test them with the recipes that we design with this patented film delivery system, and give customers recommendations or reports on how to improve their loads. But it's open to the public. It's something that you could call in and fill out a request form and get on the schedule, and can enjoy the benefits of having your loads tested. It's also works in conjunction. We have a fully functional showroom here. Depending the showroom is full of machines that are capable of stretch wrapping and packing and palletizing, those kind of things. So those kind of demonstrations can be set up as well.
All right. Well, we want to be really respectful of everybody's time. We appreciate Rodney. Thank you very much, and ROBOPAC, for giving us this presentation today. Thank all of you who were on the call today or on the webinar. Again, remembering we'll be sending an email with a link to the webinar that will be posted on our website, so you can share with others that may find it interesting. There's also a survey that we'd love you to answer. So thank you. And don't forget about our annual event called Engage, the Contract Packaging and Manufacturing Experience, on March 3rd through the 1st in Clearwater Beach, Florida. Great place to be, in the middle of the winter. So look forward to it. On behalf of CPA, thank you all. Thank you, Rodney and ROBOPAC. Have a great day, everybody.
Take care.